As Alex mentioned, my name is Angelique Medina. I work for a company called Thousand Eyes, where alongside my colleagues, I get to work on some really interesting research projects, like looking at the performance of DNS and CDN services. The subject of this session today is to share findings that are based on a research project that had its genesis about 18 months ago, where we started looking at the network performance and behavior of some of the major cloud providers, because we saw that there wasn't a lot of independent, publicly available data on how cloud operators were running their network. So we wanted to fill that gap. So the first iteration of this research was released in late 2018 and presented here at NANOG in San Francisco last year. And the second iteration of this research greatly expanded on what we did in 2018, and that's what we're going to go through today. The initial findings from 2018 were very interesting because, as you would expect, overall network performance of the cloud providers is very good. But there were some surprising anomalies that revealed differences in routing preferences and how they manage their overall network architecture and connectivity. So in 2018, we looked at three major cloud providers, so AWS, Azure, and GCP. And in the most recent research that we did, so this was published a few months ago at the end of 2019, we added two public cloud providers, AliCloud and IBM Cloud. And we also took a look at AWS Global Accelerator, which was a service that was announced just after our initial research was published. We also added additional testing to look at intra and inter mainland China connectivity, as well as performance from vantage points that were located within US broadband provider networks. So pretty significant expansion on what we did. We also, because we had a baseline data set from 2018, we could look at year-over-year changes for Azure, AWS, and GCP, which is really interesting, and we're going to spend most of our time looking at that. So in terms of our research methodology, just very high level, the way that we derived these measurements was using a custom form of TCP-based traceroute between two endpoints that we controlled. So we had an agent at either end. We were sending probing packets between them, and we were able to look at performance indicators from that, including end-to-end latency, packet loss, jitter, as well as hop-by-hop measurements. So we could actually map out the path between these two endpoints. We also looked in both directions. So it was bidirectional. We were looking at each of these measurements independently, one way, and then aggregating those. And the measurement that we're using here is principally milliseconds. We're looking at averages. Also, because we could map out the path, when we saw anomalies, we could then go back and look at what the layer 3 hops were between the two endpoints, and we also enriched that with some metadata like geolocation and AS operator information. So these software agents that we use for this test are, they were either in regions hosted by the public cloud providers, or they were located outside the providers in hosting facilities that were connected to Tier 1 and Tier 2 service providers, or in some cases broadband providers. And they were managed by us, so that allowed us to do some consistent measuring every 10 minutes over the course of 30 days, which yielded a lot of data. And most of the data wasn't super interesting, so packet loss and jitter, not a lot to see there with the exception of China. But with latency, there was some interesting differences in how the providers performed. So in terms of the scope of our research, the questions that we principally wanted to answer were, first off, what is the performance of users? So that could be an individual or an application tier connecting to the various regions of the cloud providers. So what we did is we used vantage points across a number of different cities globally, so 98 locations. And we tested from those locations to each of the regions that you see for the cloud providers that you see here. So there was 15 regions for GCP and AWS, 25 for Azure, and then some number 21 and 17 for AliCloud and IBM. So pretty significant set of measurements that we were able to collect. Separately, we also looked at the performance for vantage points that were connected, single-homed to US broadband providers. So these were 6 providers that we're looking at across 6 US cities. And because we're just looking at users connecting from US locations, we only connected to 4 cloud regions for each of the providers. So we just looked at North America, US West, East, Central, and Canada. And then inter-region measurements were taken for each of the cloud providers between a region pair. And so there's just an incredible matrix of measurements that we were able to take. So for example, we're looking at, for instance, US West and US East and looking at the performance between those 2 points. Something that we added from last year was a baseline measurement to compare how those providers were performing relative to some baseline performance measurements. So what we did was, in the instances in which a cloud provider, let's say they had a region that was hosted in San Jose and they had another region that was hosted in Ashburn, we then, in addition to measuring between those 2 points, we also picked a vantage point that was outside of the cloud provider's network, connecting to a vantage point that was also outside of the cloud provider's network in that same city. So testing from San Jose, say, to Ashburn. And then looking at the performance difference. Are they performing same, better, no different than this internet baseline? It's just one kind of mechanism to see, if there are vast disparities or if they're, for example, as we would expect, to be much more optimized connecting between those 2 points. We also looked at the performance within specific regions. So we picked a handful of regions and looked at the performance of different availability zones within that region connecting to one another. So we picked 3 availability zones for the handful of regions that you see here. And what we're doing was we wanted to understand, for example, if an enterprise is putting together a redundant architecture they want to host in a particular region, they might choose to host in both US West 1, A and B, or some combination of A, B, and C, and that enables them to have a more resilient architecture while being still geographically hosted in a similar location. And all of the cloud providers claim that their availability zone, interavailability zone performance is less than 2 milliseconds. So we wanted to see if that actually held. One thing that we won't cover today, but something we also looked at, is the interconnectivity between cloud providers. So between, say, a region hosted in AWS and a region hosted in Azure, are there interesting things to observe in terms of how they connect to one another? As you would expect, they're very densely peered with one another. So traffic that is flowing from one region in a cloud provider to a region in another cloud provider typically doesn't go over the internet. It just gets handed from one cloud provider to the other. There is one exception to this, which I will touch on very briefly. So looking first, just to give you some kind of context for the findings that we're going to cover, there's a lot of data to unpack, so this is a little bit of a whirlwind tour. We're just going to cover some highlights and then look more closely at some anomalous behavior. So as I mentioned before, we're using a baseline to kind of get an understanding of how the cloud providers are performing relative to some baseline. So across all of the cloud providers, they performed very well. In almost every instance, the performance between region pairs was performing better than the internet baseline that we measured. So for example, IBM Cloud, 97% of their inter-region pairs were performing better than the internet measurement that we were taking between similarly located endpoints. On the opposite end of the spectrum, we have Ali Cloud, which had about 15% of them were performing worse than the internet baseline measurement we took. The interesting thing about Ali Cloud, which we saw when we dug a little bit deeper, is that unlike the other cloud providers, so across the board, AWS, Azure, GCP, IBM Cloud, when they're connecting between regions, their own regions, they always use their own backbone. That is not the case in every instance with AliCloud. In some cases, connecting between two AliCloud regions, you're connecting over the internet. And that was the same connecting to other cloud provider networks. Sometimes it would go over the internet, and sometimes, depending on their peering, you would connect directly to that cloud provider. So they were definitely an anomaly when it came to that, and it seemed to have impacted their overall performance that you see here. So quickly touching on inter-AZ performance. So we are looking here at the handful of regions that we tested. And overall, all of the cloud providers look pretty decent. They claim less than 2 milliseconds inter-availability zone performance, and that was pretty consistent across the board. Everybody does really well. A couple of regions of IBM Cloud were kind of at that watermark, 2 milliseconds, but overall, pretty good. Azure was the most consistent, so about 0.7-ish milliseconds for all of the regions that we tested. And then, for example, GCP and AliCloud, there was a little bit more of a kind of a range there. I mean, some of it was like AliCloud is like 0.27 milliseconds all the way up to, like over 1.5 milliseconds. So pretty different range of performance there. Now, these very low latencies, some of it of a red flag for us. I mean, if you're hosting in different availability zones within the same region, you want to know that, and if you're using it for redundancy purposes, you want to know that these availability zones are, for example, have independent power sources and are differently connected, and so that they're truly redundant. So when we see this type of performance where the latency is that low, it begs the question of that, if that's really the case. Are they in a different rack? Are they a different floor of this data center? Are they truly networked and power source differently from one another? I think that's maybe something at least worth asking the cloud provider if you use them. So that was just something that kind of stood out to us. The other thing that we were able to show in looking at all of the measurements and how traffic gets routed from user locations, so these are points outside of the cloud provider networks to the various regions, is that there's really two sort of ways in which the providers prefer to route traffic. And these patterns are really consistent across the providers, again, with one exception. So there's a routing preference where traffic from user locations will primarily, preponderance of the journey to the service that's hosted in the cloud provider will take place over the internet. So you're going to be, if you're a user in Frankfurt, you might connect across the internet, and then you enter the cloud provider's network very close to the service that you're trying to access and where it's hosted. The opposite of this are the providers where they are very backbone-centric and they pull in users into their network as soon as they possibly can. So in many instances, you might see that you're entering some of the cloud provider networks within just a few hops, and then you're going to be riding their backbone all the way to the service that you want to reach. It doesn't matter where it is in their network. It could be on the other side of the globe. You're effectively going to be primarily using the cloud provider's network. So these are very distinct approaches to routing users to services. And like I said, from a pattern standpoint, they have very kind of clear preferences across the providers. So Azure and GCP, they have a very extensive edge, and users connecting to services hosted in those cloud providers, they get pulled into their network very, very quickly. So the traffic doesn't spend very long on the public internet. You're primarily going to be riding the backbone, and that goes for both forward and reverse path. So a lot of the service delivery for users for services hosted in these cloud providers is going to be delivered by the cloud provider's network. AliCloud and AWS, very different. They prefer to keep users on the internet as long as possible. They don't use their backbone as much. So, again, you're going to be subject to the performance of ISPs depending on where you're connecting, where your user is and where the region you're connecting to is located. And then kind of this third category that we saw this year was IBM Cloud. And they have a hybrid approach, I guess you could say, where in some parts of their network, you are pulled into their network very quickly and you're going to ride your backbone for certain regions, like Ashburn is an example of this. And there are other regions where you're going to be connecting over the internet until you're almost, right on top of the service. So predominantly, again, like very different approaches. IBM is kind of a mixture of the two. Does this make a difference in terms of performance? We'll see that in a moment. I think overall, there does seem to be an impact, but it's not as clear-cut as like the internet is worse or the backbone is better. It really depends on some fundamentals, like how you're implementing routing and whether you're optimizing, and you can have issues whether it's a backbone or the internet, and we'll see some examples of this. So some of the more interesting things that we're going to share today are around kind of comparing differences between what we saw in 2018 and what we saw in 2019. So this is just looking at the three providers that we looked at in 2018. So we have AWS, Azure, and Google. And this is for users from regions around the globe connecting to a region hosted in Mumbai. So this is just for this one region, 98 locations globally connecting to Mumbai. So what we see for users that are located in Asia, so you can see that on the left-hand side, AWS is yellow, by the way, and then blue is Azure, red is GCP, in case you can't see that. And so what we saw was that not only was latency higher for AWS, but the variation, effectively the range, the min-max, what we were seeing in terms of latency measurements was just so much more extreme than it was with the other providers. Now, one could argue, okay, well, if you're connecting from locations in Asia, maybe the connectivity service provider performance isn't as good as maybe you might get in North America, so could that be contributing to the latency? Well, interestingly enough, if we look at the difference this year, latency improved, and also the variability and the performance numbers that we were seeing also improved as well. So they were more consistent in their measurements. Bear in mind, they haven't changed anything in terms of their preference of routing users over the internet. So it's not likely that that was the source of the issue. And in fact, we'll look at an example of what the issue actually was, or some examples of that. So it's interesting to see that even though they're using internet connectivity, they still are able to affect optimizations and make improvements year over year. And of course, this is just looking at their regular service. We'll come in a few minutes to how they perform from the Global Accelerator standpoint, which is meant to do what Azure and GCP do as a default, which is allow users to ride their backbone to services. So this is a couple of examples of what we saw and what was contributing to some of the higher latency numbers that we were seeing. So on the left-hand side, you see two green dots. The top one is a vantage point that's located in Seoul. Sorry, I know the text is quite small. And so that location, traffic connecting to that Mumbai region, you'll notice just the huge number of hops. Those blue hops that you see there, those are ISP network hops, and the green dots are AWS's backbone. And there's just, again, from a proportion standpoint, you see it's a lot of time spent on the internet. The reason for that, it turns out that users that were in Seoul were getting connected through New York. So they were effectively circumnavigating around the globe to get to a region hosted in Mumbai, which if you pull out a map, you'll see that that's really not the optimal path from Korea to India. So that was introducing a lot of latency and then, of course, contributing to the performance difference that we were seeing there. Now, what changed in 2019? We can see here that there was actually some changes made in terms of how traffic was getting routed. So we see from that same location, Seoul, that they are then connecting through Singapore to connect to AWS's network. So they're not going around the globe. It's not that, odd suboptimal path. Same for Singapore. So one of the differences we saw was an Equinix facility popped into the path, and there's really just a few hops between that location and a more optimal, connecting directly through Equinix to AWS's network. So even though, again, they favor the internet, they still were able to make these optimizations for routing customers to them. So another interesting thing that we looked at was GCP. So one of the things that we saw, and again, they favor their backbone. They had really significant latency difference compared to Azure and AWS. So why is that? So when we looked at the actual network paths, we could see that traffic from users in Europe was, again, getting routed around the globe to India. GCP really does favor their backbone and using their own connectivity, and they don't have, they did not have last year direct connectivity from Europe to Mumbai or India, and so they were routing traffic around the globe to get to that point. Now, at NANOG last year, when we presented some of this information, someone from Google stood up and said, well, actually, they're going to be making a change to their network infrastructure, going to be adding direct connectivity to India from Europe. So this year, we were really excited to retest and see what difference that made in terms of performance. And what we found was there wasn't really any difference. It was almost identical to what we saw last year, which was really surprising to us because if you go to Google's published infrastructure network map, you can see that, in fact, they did add direct connectivity to India. So they had infrastructure, they had the fiber, they were leasing or they owned it, but we were still seeing this circuitous path that was taking place. Users, again, they were getting pulled into Google's network in Europe, and then they were riding their backbone around the world to India. So we actually reached out to GCP and asked them about this, and they had said that they were still in the process, even though they had the infrastructure in place, they were still in the process of rolling out these routes to all of their regions globally. So what they had said was it's still kind of in beta, and they expect to do that over the next few months. And they had said, though, that this route was available for users who were in the Middle East. And we were testing from Dubai, and we were not seeing that. For Vantage Point, the user in Dubai, they were also getting routed around the globe. So they weren't taking this new path, but we do expect, as GCP said, or Google says, that they will be rolling out this new route to more regions over the next few months. So when we test later this year, we'll hopefully see some improvement in performance. So this is also not explicitly performance related, but I think it's worth noting because this was a change from 2018 to 2019. And that was that for the path that we were mapping out when we were testing from locations outside of GCP to a region hosted in GCP, it didn't really matter where it was, that we suddenly were losing visibility into the reverse path. And this was across the board, so it wasn't specific to a particular region. It was just a change in or in terms of the visibility that we had. So what was the root cause for this? Well, if you go to GCP's network help pages, so they've done some publication on this, and they basically have said that they've made some changes where any trace route that's bound for an internet destination, so this is not the case across their own network or anything that's inbound, really anything that's out on the internet, they are adding to the TTL counter. And so because of that, that's effectively breaking traceroute. I mean, they said that Depending on the number of hops, there may be, you lose some visibility, but the result that we've seen, and I don't know where they're placing that counter, my guess would be some really high threshold like 255 or 128 or something like that. It didn't matter really where the user was located. There was no decrementing of the TTL enough so that we were actually able to get any response. And so because of that, we can't see the reverse path, which I think is interesting to note because there is this trend towards the cloud providers starting to monetize their backbone. And if you don't have visibility into how traffic is routed, then it's hard to know whether or not you're getting the specific service that you expect to see. We're running kind of low on time, so I'm going to breeze through some of this stuff. So performance from China, I would say that overall all of the providers do pay a toll. It's not like AliCloud or any other cloud provider is not subject to the same issues for any user connecting from China to a region outside of China. This is packet loss, so pretty high across all of them. Again, don't really have time to look at this too much, but there are some viable locations to host in outside of China, not only from a packet loss, but also from a latency standpoint. So Hong Kong, good options, Azure, AliCloud, all look pretty decent. So for vantage points from China, where we wanted to just look at strictly for you as broadband providers connecting to regions that are in North America. So as you would expect, overall connectivity is really strong. From Chicago connecting to Azure East, of course, it's going to be a lot lower than anything on the West Coast. But we did see some really odd stuff, like, for example, from Verizon on the West Coast connecting to a GCP region that was hosted in LA, really, really significant levels of latency, just really bizarre. And so we looked more closely at that, and what we found is that traffic was connecting into GCP's network in New Jersey. So these are from West Coast locations, and then it was hairpinning along GCP's backbone and getting connected to LA. So it didn't really matter that you were connecting into their network, or that they are more backbone centric. This was still a routing issue that was impacting users, and it wasn't optimal, obviously. We alerted them to this. They very quickly made a change, so you can see this sort of dramatic drop in latency for users on the West Coast, and then it just kind of went back to what you would expect to see if you were in that region. Global Accelerator, this is a really interesting one, so I'm going to try to get through it in a minute. So this is effectively designed to pull users onto AWS's backbone very quickly, so closer to where the user is located, and that works bidirectionally. So you're going to have more of the service delivery that's done by AWS versus over the internet. So how did it perform? As a premium tier service, it depends. It wasn't uniform in terms of improving performance. We saw instances, so the green is where performance was improved, and orange is basically where it was effectively the same as their regular way that they route traffic. And then red was where we saw it actually they performed even more poorly compared to their standard way of routing. So it really depends on the location, and they are, in fact, working on optimizations when they saw some of this stuff. So as an example of this, we tested in October. They said they were going to be making some changes, and we did, in fact, see an improvement in some of the locations we looked at where it wasn't as great as we would expect it to be. So they are responsive. I would say across the board, cloud providers are in general very responsive. If you show them where there's an issue in terms of routing or performance issues, they will usually try to do their best to make it right. So just as summary, very quickly, so cloud provider preferences, they vary. It's not uniform. It could be more internet-centric, backbone-centric. It's really up to the cloud provider, and that can change over time, too. Inter-region connectivity, pretty good, and really just rides the backbone across all of them, except for AliCloud. AWS Global Accelerator, you want to know that you're getting the performance you expect, so you can't necessarily assume that just because you're paying for higher level of network service, that's exactly what you're going to get. So definitely make sure that you have some visibility there. And then GCP Europe to India backbone route, it's still kind of rolling out across most of their geos. So that should be something that we will see over the course of this year. Takeaways. Things change. Trust but verify. Of course, the cloud providers want to do right by their customers. They operate massive global networks, and sometimes in optimizing things or making changes, it can have unintended consequences. So you want to make sure that you can see what the impact is of those changes. Really important to get visibility into how your cloud provider is performing for you. If you want to see the fuller report on this, you can download it at this web address, and the obligatory social media plugs here. So my Twitter handle is @bitprints, and my colleague, who's the lead author of this research, Archana K7, can be reached at Archana_K7. If you have any questions, we can be reached there. I don't know if we have time for questions. We don't. Okay. Well, if there are any questions. Okay. Who wants to go first? Okay.
David Paul Zimmerman, LinkedIn. Did you capture and or look at any data IPv4 versus IPv6?
We did not, no. So we were just looking at IPv4. We have done IPv6 for some other research that we've done. That may be something that we cover in the next, it actually was something on our agenda to look into and potentially include, but we were pulling in so many new things that we just decided to hold, so we might do that later this year.
Hi, Avi Friedman.
Hi.
Question, so every 10 minutes you're doing these tests. How many packets are actually between each of the zones or external regions, so not like the trace, but that are actually hitting each end?
So you're saying how many packets are being sent in each direction?
Right.
Roughly 50 packets.
Okay.
Yeah.
That'll hit each end. Okay.
Yes.
Cool.
Yep.
Thanks.
Yeah. Okay, there you go.